Welcome to this module in our titration video series, in which we're going to be covering policy, ordering, and hierarchy. Honestly, one of my favorite topics in titration. I'm joined by Rob, and I'm Tim. So, Rob, policy, hierarchy, and ordering. We've been talking about the fact that we have the capability to sandbox the application developers, provide them guardrails so that there are policies that are in place by default, yet giving them the flexibility to control their own destiny and decide exactly what their application in specific should be doing. And the way that we achieve that sandboxing, the way that we as the centralized IT team can control those application developers is via that policy, ordering, and hierarchy.
Yes, and Tim, I think this is one of the most powerful features of titration, right? The ability to actually have the ability to define policy at different points with an ability to have a prioritization and ordering of that policy so we end up with the right overall policy result.
Yeah, this really is one of the most powerful features of the titration policy engine. It's not complicated, but it does take a little bit of time to get the concepts settled into your head. So that's why in this video we're going to hopefully lay out exactly what the policy, ordering, and hierarchy looks like and what that can enable you as an end user to do with titration.
Cool.
So we're going to start with some slides just to discuss the concepts of how the policy is ordered. And then we're going to work into a demo where we'll go through changing around some different policies and see the effect that that has on the application workloads.
Great.
So let's get down to the first slide, which is where we're going to talk about the policy ordering inside one scope. So we've talked about scopes in many other modules already, but we know that scopes is a collection of workloads that are going to have some policies enforced on them. And inside that scope, we have a set of policies, absolute and default rules. Okay. We've touched on this already, right?
We have, and I guess we've got different types of policies that fit into this model, right, Tim? So there are the discovered policies. When we run an ADM against our scope and our workspace, we get some policy results. So how do they actually fit in again to this model?
So when we run application dependency mapping, or ADM, they are generated as default policies. So that would fit into this middle portion of the policy here. But we also have absolute policies. So what are the kind of absolute policies that you typically might see?
Well, these are the kinds of overrides that we as maybe an administrator might try and apply. And now, whether that is that we always want to permit something or potentially we always want to deny something, it's our ability to really give some human definition to what the outcome could be. Now, there's, I guess, common scenarios around prod and non-prod being able to talk together. Maybe it's also ensuring that there's specific access to services that you always want to make sure are actually included in the policy as well. Okay,
so these are going to be most commonly generated policies, and absolute policies are going to be, in most situations, ones that are written by an administrator or an application developer.
That's right. Yeah.
And inside that one individual scope, if we treat that as a ordered list of policies, they're going to be executed from top to bottom. So as we're processing a packet, we would check the absolute rules first, then the default rules, and then finally we would hit the catch-all rule within inside that scope.
Okay.
From top to bottom.
And Tim, so we often talk about the whitelist policy, right? Now, we've got the catch-all deny at the bottom. There's some scenarios where we might actually set this to permit as well?
Yeah, so typically we would see that the catch-all policy being deny is placed at the most specific part of the scope. That's when you want to elect an application to be in whitelisting mode. However, when we're talking about some of the other places that you can place policy, let's say, for example, a scope that's higher in the scope tree, maybe applying some global policies, we would typically recommend that you set your catch-all in that scenario to allow, because you want to not impact every single application and force them into a whitelisting mode.
Okay, so in this case, we're really dealing with an application really at the leaf of our scope tree.
Yes.
And typically that would involve a policy that we've perhaps built through ADM, and also potentially overridden with some absolute policies, but with the catch-all deny.
Yes.
To actually take that policy, and when we're ready, once it's been validated and tested, then we can enforce that and deliver the full control.
Yeah, you got it.
Okay.
So this is within inside one scope, but we know that there are multiple scopes in the scope tree, and you can have a workspace per scope. Yet ultimately, only one final set of policies get enforced on the workload. So the question that arises is exactly how are those scopes related to each other, and how do all of the policies from those scopes get merged into that final output?
That is a great question, Tim.
It is, so let's get
you're
stuck
gonna
into
show me
it.
how that happens. Yeah.
Right, so if we look at a scope tree, this is the scope tree that we've been working with throughout this video series from our Acme organization, where we have the cloud layer, the banking layer with the core prod application. So in our environment, we have a number of different workspaces. We have a workspace at the cloud level, we have a workspace at the banking level, and we also have a workspace at the core prod level.
Okay, and this is the one that we were just looking at, right? So
Yes.
where we've got our application policy and our catch-all or deny.
Correct.
Okay.
So the previous slide has just been merged right into that bottom one.
Okay.
But we also have these extra workspaces that have their own ordering of absolute, default, and catch-all.
Okay. So what would be maybe an example of a policy that somebody would apply, say, across a set of applications? Because this is hierarchical, right? So if you were to apply policy here, it would apply this set of policy to any of the applications in the banking service tier.
Yeah. So what you might find, for example, is in the banking service tier, that might be specific regulatory policies that apply to the banking applications, but wouldn't apply to any applications outside of the banking scope. On the other hand, you might see some of these policies higher up in the tree. Those policies might apply to every single application, no matter what type of entity it is.
Okay. Right, so we might have maybe some regulatory compliance here, perhaps some InfoSec policy at the higher layer. So just stuff that we want to be adhered to by all workloads in our environment.
Yes.
Okay.
And we would typically recommend that you start with the more generic policies up top, and as you get deeper into the scope tree, you become more specific with the policies that you are building.
Okay, so if I define a policy once up here, who actually gets that policy? How does that work?
So everyone is going to get the policy lower down in the scope tree.
Yeah.
But exactly how that policy is going to affect their workload is going to be different based on whether it is a default policy or an absolute policy.
Okay, so it's based on the ordering that we get there, but the goal is I can just do it once, and it doesn't need to necessarily be repeated over and over again throughout the environment. Right?
It's really, really powerful to you, especially if you're on the administrative team and you get some sort of request, like we need to block all of this type of traffic across my entire environment, or I need to open up a port on all of my workloads to a particular service. Doing that in one single place and having it apply to every workload without having to repeat that policy over and over, it's a massive time saver, and it honestly reduces the complexity of deploying those types of policies.
Okay, excellent.
So you're going to start thinking about what are the kind of controls that I can apply. Can I deny traffic? Can I allow traffic? Can I allow the application developer to override those? And the answer is yes to all of those.
We like a bit of flexibility here, Tim. That's great. Great outcome.
And the thing is, we have to provide that flexibility. There is no one way that you can enforce something. It comes down to the exact environment that you're dealing with, the requirements of those applications, and also the requirements of the business. So we need to provide that flexibility, and we do that through the absolute and default rules. And let's unwind exactly how we can do that so that it makes some sense to us.
Let's see it play out.
So if we take these three workspaces and apply them into our global policy ordering, again, there is a second set of ordered policies. We know that they go from top to bottom, from the least specific policies at the top of the tree right down to the most specific policies at that individual leaf level.
So you're saying it's just going to just top down, just straight down through the list here, Tim?
So I'm not saying that.
No?
And that's why we're going to get into a little bit more detail, because it is not quite that simple. And that's because we have to provide the power so that you can actually allow or deny things in the way that you would expect to. So there's typically two use cases that customers are striving for. I either want to absolutely make sure that everyone inherits this policy, or I want to apply a policy by default, but allow the application owners, allow the lower members of the scope tree to override that default policy. That's the real two main distinctions between the types of ordering that we provide in Tetration. So you can think about the absolute policies as those ones that are either regulatory or must be in place for an application workload to exist. Like, you must be able to access our DNS servers.
Okay.
You must allow our security scanner to access you, or you must not talk to a PCI compliant database. Those are typical absolute policies.
Right. Okay. And then anything beyond that is sort of more suggested with the ability to be overridden by these absolute policies.
Yeah. Let's say we suggest that you don't allow port 80, or we suggest that you don't open up port 22 for SSH. However, if you must, you may actually override that and allow that in your policy.
Got it. Okay. Sounds very powerful.
It does.
So how does that...
And let's see how it plays out.
Yes.
Because it's actually really not that complicated, but once it's laid out for you, hopefully it will all make sense.
Okay.
So there's the global policy ordering from top to bottom. And we will take the absolute rules of every workspace and apply them first. So let's visualize that. We're going to take the absolute rules from the inside workspace, from the banking workspace, and the core prod workspace, and put them into the global policy output.
Okay. And I noticed that went so top to bottom in that order, 1, 2, 3.
Yes.
All right.
And when I'm referring to the global output, remember there is only one set of ACLs that can be enforced across the entire data center.
Okay.
Each workload is going to get a specialized, optimized version of that ACL, but overall there will be one consistent set of policies that are enforced everywhere.
Yep.
So we have to resolve any conflicts, we have to resolve this merging before we can enforce those policies, and the absolute rules from the higher level scopes apply first.
Okay. All right.
And that is why any rule that is applied at the top level overrides anything lower in the stack.
And this is why it's important to get our role-based access control configured correctly, right?
Yes.
So you don't let anybody just have global control across all scopes. We will actually want to have a certain level of administrative access and control higher up in the scope tree, and then potentially offer other teams access to really their points of responsibility in the tree.
Exactly.
Yeah.
There's that old quote, with great power comes great responsibility.
Yes.
If you have access to that higher level part of the scope tree and you're going to be building policies there, do keep in mind the fact that they will apply to every single workload in the environment. So be aware of that as you enforce those policies. And we're going to look at how policy analysis actually will help you see the impact of your changes.
Excellent.
Now, when it comes to applying the default rules, remember, these are the ones that we would like there to be there by default, but the application owner can override them if they choose to do so.
Mm-hmm.
So to achieve that, we actually unwind the policies in the opposite order. We apply the default policies of the lowest scopes first, then moving to the highest scope afterwards. Or I should say the leaf scopes first, to be clear.
Okay.
So if we animate that onto the slide here, you will see the core prod default rules come first.
Right.
So if I had placed a deny rule at the Acme inside level, that would not override a allow rule at the core prod level.
Got it.
So that gives me that flexibility to define some of these default rules, yet allow the lower leaf nodes to override those policies.
Got it. So we've gone with the absolute policies from top to bottom through the tree.
Yep.
And then we've taken the default policies and we've gone from bottom through to the top.
Correct.
And we've laid them out in an order here, which will then be ultimately assessed from top to bottom.
Correct.
Okay.
Just always think about this really as an ACL, if you're comfortable with those kind of concepts. It is just an ordered list applied from top to bottom once we get to this global ordering.
Yeah, so tetration is effectively aggregating different sets of control into one ordered policy and then combining that and assessing it to deliver to the workloads.
That's it.
Okay.
So then the final piece of the puzzle is we need to work in the catch-all rules. And as we discussed earlier, you want to allow flexibility for individual application owners to elect whether they would like to be in a whitelisting mode, and you don't want to enforce that on every single application if they are not yet ready for whitelisting. So that's why we also apply the catch-all rules in reverse order. We apply the catch-all rule that is most specific for a given workload. So in this case, we're going to apply the core prod catch-all before those of the Acme Inside and Acme Banking. So let's animate that out. We can see the catch-all of the lowest scope, and then we see the catch-all of the one that's Acme Inside.
All right, that looks pretty complete there,
Yeah.
Tim. And if there were any other, let's say, policies in different parts of the scope tree, maybe in a different a different app or service that was not banking related, that's irrelevant to this discussion here, right? It's not part of that path through the scope tree to reach these workloads, so therefore they will apply to a different set of workloads.
Different set of workloads.
Okay.
Yes, that's it. There is a flexibility there so that as you move down each arm of the scope tree, you're going to get a separate policies based on the lineage of that particular workload that sits in that scope tree.
Okay.
So we have our policy here. We have the absolute rules applied, we have the default rules applied, and then we have the catch-all rules applied after that. Top to bottom, bottom to top, bottom to top.
Okay.
There could be an acronym in there somewhere.
It sounds simple.
Yeah.
All right.
And always remember, because it is the most specific catch-all that is applied, this is a deny catch-all.
Yep.
If we don't match a particular allow in this case, it is going to be dropping that traffic. And that's why we would use policy analysis to make sure that we've validated that workflow, we've validated all of those policies before we go and actually hit that enforce button.
Okay.
And one of the nice things about policy analysis is, well, it's going to do this work in the background for you.
Yep.
You don't have to be calculating exactly what the ordering is, and it's going to show you the effect of that ordering.
Yep.
You can even analyze it to see exactly how that ordering came about.
So if I was an administrator and I decided to make a policy change, say up here in the scope tree, how long would that take to actually, for any workloads that were being enforced with that policy, how long does that time actually take to deliver that through to the workload?
Yeah, so as when we edit any policy, it's always going into a staging mode first. So you edit the policy in the user interface, but that's not going to instantly reflect it on the workloads.
Yep.
You can go through the policy analysis, you can update your policy analysis policies, check the effect of it, and you'll be able to start seeing results within about a minute. Although obviously I would recommend if you're making a big change that you might take some more time to look at the analysis of that policy.
Yep.
And then when you actually choose to update the enforcement rules, we're literally talking about 60 seconds from the enforcement of that policy to it being reflected on your workloads.
Okay.
So let's say that you actually had some sort of breach that you wanted to contain or some sort of outbreak of malware. You could write a policy that denies the traffic pattern of that malware at the very top level. And once you enforce it, that's actually going to be affecting your workloads within 60 seconds. So you can really react to those advanced threats very quickly.
Okay, so I could write policy up here that may be based on how to handle a specific vulnerability or some threat in our environment, and then I want to make sure that anybody that matches that is potentially exposed, we've got an extra layer of protection that's going to be built in, and we do it at one place.
Yes.
Okay.
And obviously, because we're also refreshing our policies every 60 seconds, detecting if any workload has changed identity, that means, for example, if a workload comes up that has a new vulnerability, or we have an annotation applied that asks us to quarantine a particular workload,
Got it.
every 60 seconds, we don't have to change the policy as the end user, but Tetration is going to be recalculating what has to happen.
Got it. Excellent.
So we've seen this in theory. We could move to a demonstration now so we can actually play this out in real life and see the effect of these absolute policies and these default policies.
I think we should, Tim.
So what we have up here is our global policies that we were looking at in our earlier session on application dependency mapping and also in our policy enforcement module. So we previously just had a couple of allow rules allowing access to DNS, titration, and statistics. But I've added in a new deny rule. And you will notice that this is under the absolute policies section. So Rob, take a guess when I've said I would like to deny traffic from the cloud apps scope to the services scope on any port. What's going to happen?
I have a feeling that's going to be somewhat disruptive, Tim, to
Yes.
our applications, because that is a deny in an absolute policy at a high level. So everybody in cloud is going to receive this and evaluate it and deny traffic between apps and services.
Yeah, I've effectively banned communication between the applications and the services tier.
Okay.
Clearly, you wouldn't want to be doing that
That's a
in
bad
real
day.
life.
Did you log in as Remy?
I did. I made sure that the traceability says Remy did this. And you will see that when we analyze this under policy analysis, we'll see the impact and the effect that it has on our workloads.
Okay. We've
clearly chosen an example here that's going to be incredibly disruptive. you have the power to choose what these policies look like, it always makes sense to do policy analysis beforehand.
Yes.
But it does give you that capability as the administrator to predict the effect of your changes. No longer are you going onto a firewall, making a large change and just crossing your fingers that no one gets on the phone saying you broke my application.
Yeah.
So we have put this policy in place, and we've come over to the policy analysis tab. And we, just a little bit earlier today, we clicked that we would like to analyze those policies. So you can see this P2 flag is where I added that absolute rule.
Mm-hmm.
Again, we're just in the analysis mode. We're in the policy analysis screen, so we're not actually affecting
You
any
haven't
traffic.
broken anything yet.
Still not broken
That's good.
anything.
Okay.
No one's mad at me yet.
Yeah.
So we can see that the traffic went from 100% permitted, everything was allowed as per the policy, to changing to around 67% being allowed, but around 32% of that traffic being denied, or I should say it is non-compliant based on the new policy that we would like to enforce.
So this is kind of like the what-if scenario.
Yes.
Like I'm going to make a change. I'm not really sure of the impact. Let's just test it before we hit the button, right? So before we're not waiting for the call. We're going to determine what we're going to impact first.
And at this point, either we would back this change out, or this would give us the capability to actually look at these flows, so we can hide the permitted, and we can just look specifically at those escaped. And then we can get more detail about those escaped flows. So I can see, for example, that would impact the banking app standby speaking to the service message queue there.
Okay.
So I actually know not only what am I going to break, but I know who I'm going to impact. Which applications is this change going to impact? So we know in this case, because it's an example, we are going to be denying all of that traffic between those application services and those applications. And that might be what we want, probably not what we want, but it shows that the way that you can control what the application developers do.
Yep.
Despite the fact that those application developers asked to have that allowed. So if I open up this flow, and we'll be able to see some more information about this flow. So it's been lasting for about a day. Clearly, it's pretty important. This is a major control channel between these two different workloads. And I can see that it is the banking app process. And more interestingly, when it comes to the policy hierarchy, I can see exactly why that flow is going to be denied.
Okay. So what that means is very quickly I can filter out all of the things I don't so much care about. I can get very specific to the flows that I potentially impact and understand why, even before I make the change.
Yes.
Okay.
And even further, we can actually understand why is it denying. So we can see the final policy decision. We know that it's going to deny, it's going to drop this traffic. But if you want some more information about exactly why is it chosen to deny that traffic, we can click Quick Policy Analysis. And Quick Policy Analysis is available both for the users in the higher level scope in this global policies, but also in the application specific scope. So the app developer, while they might not have control of this policy, they can see what the policy says so that they aren't going to be frustrated about, why is that traffic being dropped? Who put that policy in place?
Yeah. Well, I mean, that's the big thing that happens. If anything goes wrong, everybody wants to know why and to be able to remediate it really quickly. So it's a very quick way to understand it wasn't something I did, somebody else made a change. Who was it, what happened, and what's causing the problem that I'm actually facing right now? Okay.
Yeah, and that's really going to reduce the frustration between those two teams because it's not such a black hole of communication anymore. So I clicked Find Matching Policies, and what that did was look through the policy engine that Tetration is running and give me the output for this specific flow. So when this client speaks to this server on port 5672 TCP, exactly what policies could potentially apply to that flow.
Okay.
It's showing the policy decision is deny, but if I look on the consumer side, and remember that every single side of the communication in Tetration is analyzed as a different entity, the consumer is different from the provider. So on the consumer side, on the application side, we're saying there's a number of policies. Now the one that is most specific, or the absolute policy here that you can see, is from the cloud location, which is the global policy set, says deny any traffic between apps and services. Yet the application developer had a policy in place that says, I would like to allow that traffic.
Right.
But because they don't have that way to override it, because they cannot override absolute policies from those global policies, this is the one that has the final policy decision, and that is exactly why that traffic is dropped.
Okay, so what this is showing in this page, so firstly you just clicked one button to have this pre-filtered view just for that specific communication to say show me the policies, and here we've actually got, if I remember the animated output of policy where we brought all those things and we put it in an ordered list, we've actually got the same thing just specifically played out here for us, right? So
yes.
We've got the absolutes, of which there is only one. We've got the defaults, of which there is also currently only one. This was actually coming from the app itself. And then our two catch-alls, again, from the bottom of the tree further up. So we see it all play out here. Clearly, this is the point of the issue. What can we do about it, Tim?
Well, it depends how nice we're feeling. Do we want to go ahead and enforce this policy and break all the applications?
I'd say that's probably a bad day out for
I think
most
it would
involved.
be a bad day out for everyone.
Particularly Remy?
We can, particularly Remy, because it's going to be his name that's on the change request. So what we can do is let's go play with moving that policy from absolute to default and see how that impacts the output of the policies here.
Right. So in other words, we're turning it from a this must never happen across the board to we sort of suggest, but you can override if you want.
Exactly.
Okay.
So we'll take this policy out. We'll remove that and make this one inactive. And then we will go replicate that same policy under the default policies. So we'll add a default policy. The priority ordering in this case, just for your information, is only the ordering inside this application workspace.
Okay.
It is not relevant to the global policy ordering.
Yep.
And we're going to say we would like to deny apps speaking to services, and we're going to put any again. So we've constructed the policy in exactly the same way, apart from the fact that it is now a default policy instead of an absolute policy. We've also moved over to our policy analysis screen, and we've analyzed these latest policies to reflect that change in that update. So let's take a look at the demo now and see exactly how that has impacted the policy analysis graph. So if we move our cursor over here to the latest data that we have available to us, we will see that after the change in policy analysis, where we changed from absolute to default, the escape traffic has completely plummeted. And the permitted traffic, if we show that, has come back up to 100% again.
Okay, that sounds like a much happier place than we were before, Tim.
This sounds much less likely like we're going to get a phone call from the application developer. So despite the fact that there is that deny rule in there, because it is a default deny rule, we're not actually seeing that traffic going to be dropped, or based on the policy analysis, we know that traffic is not going to be dropped. And in fact, we can even search down for that particular traffic. So we will say hostname contains service message queue. And here we can see that traffic went from being escaped based on the absolute policy, moving over to being permitted based on that new policy update that we created. And if we select one of those flows, we can repeat that same task where we opened up the flow to view information about that flow. We then scroll down to the quick policy analysis, where we can initially see that that traffic is now allowed. We can see that that default policy of the specific application is overriding that deny.
Yep.
And if we want to, we can click quick policy analysis again. What that's going to do is pre-populate this query with the right flow details. We're going to hit find matching policies, which will then go ahead and list out exactly what the back end of the system is doing. So you can see that the final policy decision now has been set to allow. And if we look at the ordering of the policies, we can see that the default policy of the banking core application is actually considered to be more specific and therefore overriding the default policy of that global set of rules.
Okay, so in this case, there were no absolute policies written anywhere in this particular line of the scope tree. We hit the defaults in the correct order, which means that the application owner gets their desired outcome.
Yes. So again, we've set the boundaries of the sandbox, but in this case, we've set the boundary to be slightly flexible, and now the application developer has overridden that with their own particular choice.
Okay.
So hopefully that gives you a little bit of information now about the two ways that you can construct policies: absolute policies, default, and the way that they are ordered globally as we build that final set of policies.
Yep. I think it's one of those things that when we talk about the hierarchy, we talk about policy at different points, it potentially could be complicated. But the actual benefits of actually getting there and the way that we've actually got the ordering of the policy actually makes it a really simple way to apply a comprehensive policy to the workloads.
Yeah. Once you really get those constructs down in your head and you are comfortable with exactly how absolute and default policies are ordered, you will suddenly see all of the opportunities open up to create these interesting policies that actually provide you, at the end of the day, much deeper levels of control with higher levels of flexibility than you may have ever had in the past. So thank you for joining us in this session on policy ordering and hierarchy. I hope you found that useful, and now you have more comfortability with the concepts that are available to you. If you would like more information, please visit cisco.com/go/titration.